So, hello, my name is Andrea Valle. I will talk about SuperCollider. Um, on the screen, you can see my official email. By the way, is the email I always use. So it's a way to contact me if you need to, and you can find me also on social network, in particular on Facebook if you want. So we will stay together for the duration of some video tutorials, so you will have to get acquainted with my specific Italian flavored English, and I hope it will not be not too much difficult for you. We will speak about SuperCollider, and as you can see, I decided to put my face on a small square in order to place it, to have on the background the SuperCollider application, so that we will be able to see SuperCollider at work. So what is SuperCollider? Well, actually, SuperCollider is an environment, a software environment to generate sound, so to generate audio and to compose music. These two aspects are not the same. First of all, because audio is mostly referred to in terms of technical capability at a low level, while music typically refers to the possibility of organizing sound at a higher level. An interesting point in SuperCollider is that these two aspects are tightly integrated, so there is a unified environment. Now, the first point is what do we refer to when we speak about SuperCollider? Well, it might be not so easy at a first glance. And in order to show you what SuperCollider, the term SuperCollider means, I can use a picture. Now, the picture is the one you're seeing here, and actually this image, this schema shows the various meanings of SuperCollider. Now, first of all, where do you find SuperCollider? Well, actually, you find it on the web, and in particular, you find it at supercollider.github.io. Well, let me check. The SuperCollider is wrong. SuperCollider is the right one. Let me check it for you. And let's see here. Now you can see the website. So this is the official website of SuperCollider. You can see that it is SuperCollider github.io. It means that the whole software project is kept on GitHub, which is a versioning system and a site for this versioning system, which is used by developers from all over the world. And in particular, GitHub is mostly used for open source programs. This means that SuperCollider is an open source program, so you can download it for free. There's a quite active community working on it since the community since 2002, as you can read on the website. And the other interesting point in SuperCollider is that it is a multi-platform project. So I am actually on Linux. I've been for many years on Mac OS X. If you are on Windows 2, there are no issues at all. There are very few issues related to different platform, and these issues most probably will not be relevant for us during these videos. So you can go to this page and you can download SuperCollider. It should work without any issues on your machine. If you're on Linux, you will have to sorry, you will have to compile it by yourself. Actually, I'm not at all a Linux guru, but I've been able to compile it, so there should not be any issues related to the installation of SuperCollider, and it will work. And so when you download SuperCollider, you download a software package. So the first meaning of SuperCollider refers to the whole application you download. And now we can go back to our schema, this one. So you see there is a complete block here, and when you download SuperCollider, actually you download everything substantially. You mean you are referring to the whole application. Fine. Now actually this whole application features 3 components, 3 different components. These components are tightly integrated, but they are autonomous. So here you can see the screen when you open the standard application. What happens here is that you have a space where you can write, and in fact I wrote my email address and SuperCollider website address, and here you can see that you have some information concerning the software, so the help system. In fact, there is a tab here which is named Help Browser. There is another tab which is Post Window, and it's an information, it provides information concerning the way in which SuperCollider is actually working. Now, when you open SuperCollider the first time, you will probably not see these kind of organization of these 3 blocks, meaning the writing window, the post window, this one, and the help system, because I have rearranged the these 3 blocks. You can rearrange the way you prefer. This is the standard way in which I like to see my installation. So you download SuperCollider, you open it, and you get this. What is this? Well, actually, this is the Integrated Development Editor, IDE. The IDE can be seen in this diagram here on top. So we are using the IDE, the standard IDE. Now, what is an IDE? Well, actually, it's simply a text editor. You see, I can write things here like this, which is integrated with some development tools that helps you programming. Now, this means that it's, of course, related to SuperCollider, but some more advanced users might want to use their own favorite integrated development editor, such as Emacs or Vim or Atom or whatever. So this is actually possible. Of course, we will use the standard one, but this is an interesting point because it means that we are working on a piece of software that can be taken away and replace it by another. So when we say that we are looking at the post window, it means that we are working here. We are looking at SuperCollider post windows. It means that we are working at the level of the integrated development editor number 6. So we're downloading this whole block number 4, and we are starting using number 6. I said that the SuperCollider is an environment. Why environment? Well, because it's sort of, let's say, micro universe with different things put together and working together, hopefully in harmony. So the first thing that we have introduced is the editor, but actually the editor by itself does nothing, because it's just a text editor, like other text editor, like well, not exactly Word, because Microsoft Word is a word processor, but actually like a text editor, the standard text editor you find on your operating system. So the point is that what we will write in this editor, that is actually here, is something which is related to a specific language. This language is named SuperCollider. So SuperCollider also means refers to a specific language with some specific features that we will introduce later. So actually we will write in SuperCollider, meaning that we will write in the SuperCollider language. So if you look here, you see that there is a number 2, SuperCollider, meaning here a specific language that has been designed, devised by James McCartney, the original developer of the whole SuperCollider environment, and we will see that there are some specific features of this language. As an example, that will mean nothing to you at this point, it is an object-oriented language. Now, we will discuss about what is a language for a computer, but actually the point is that a language in itself does nothing, because it needs to be spoken by someone, and it needs, in particular, from a pragmatic point of view, it must be understood by someone. Well, of course, a computer language is a mean of communication between a programmer, that is you, and a computer, and it needs to be interpreted in order to be executed. So the point is that the language itself is not enough. We need someone or something, form of subjectivity if you want, that is able to understand this language. And this program capable of understanding the SuperCollider language is the interpreter for SuperCollider. Now, as you can see in the diagram, there is a number 3, and the number 3 is the interpreter, that is a specific software component that is able to understand the language SuperCollider. So, when we say that we are executing a SuperCollider statement, we are referring to the interpreter, because to write is just a first step. The second point is to send this statement in a specific language to an interpreter capable of understanding and running it if there are no mistakes. Who is checking if there are mistakes in what we have written? Well, actually, it's the interpreter trying to make sense of what is going on. So we're speaking to the interpreter in SuperCollider. SuperCollider is the language that is able to put together we as a programmers and the computer, and the interpreter in particularly as a mediator between us and the computer, and the interpreter must be able to understand what we are saying. And if he's not able, he will say, sorry, I can't understand what you're saying. As an example, if we ask the interpreter to understand these, we will get an error. We will dive into this error later, but the point is that you get a red written line saying error. You're making an error. This means that the interpreter is not able to understand what we want. Now, actually, this is a legal statement in SuperCollider language, and in this case, if we evaluate this line, we don't get an error anymore. So, the point is that actually what happens is that by using SuperCollider, typically this means that we are working in the editor, 0.6, and we are writing in a specific language, SuperCollider 0.2, and we are asking a program, the interpreter, to understand and execute what we have written, 0.3 in the diagram. So, is it enough? Is it enough? No, because what we want is to be able to write programs, and typically, if we are diving into SuperCollider, we typically want to make sound. And what is the component? How do we make sound? Well, actually, there is a specific component in SuperCollider which is dedicated to the generation of sound. This specific component is the server numbered 1. The server is a piece of software, an autonomous one, that is not very clever, but it is very efficient in generating state-of-the-art audio signals. So when we want sound, we have to ask the server to generate sound. And when we say that SuperCollider is really sounding good, we are referring to SuperCollider in terms of the server component, the one dedicated to generate the sound, number 1. So can we put all these things together? Yes. When we download the application, when we download SuperCollider, we are referring to the whole bunch of the application, number 5. This application is a software package containing the integrated development editor, the interpreter, and the server. When we write in SuperCollider using the standard default interface, we are using the integrated development editor. When we write code in SuperCollider, we are referring to the language SuperCollider, which must be interpreted by a specific program, the interpreter. And actually, when we want sound, we are referring to the server components. Now, the point, we are still missing one point, number 4, client. Why? Well, actually, if you think about the server as someone who is providing services, well, at this point, you can consider the one who is asking for services as a client, just like going to a shop. So think about the server as a sound shop, and you go to the sound shop and you say, I'd like to have a sinusoid. Well, at this point, you become the client for the shop, that is the server. And the server is saying, okay, I have a sinusoid for you, and is giving you back your audio signal. This means that the block, which is the application number 3, which is a piece of software, which is typically named Sclang, SuperCollider language, works as a client asking for services to another block, which is the server, typically named the server or SC Saint. I typically read these names in a sort of my specific Italian flavor. So sometimes if you're hearing me speaking about Xint, I'm speaking about the audio server. I will try to pay attention to this and stick to a server. So we have the integrated development editor, piping strings, blocks of characters to the interpreters. The interpreter is trying to make sense of what we are writing, and if and only if we want sound, is forwarding our requests concerning sound generation to the server. Now, you can find this whole organization a bit complicated, because it is. Yes, it is a bit complicated. You may also ask yourself, why this organization? Well, the point is that it surely has a bit of complexity, but it also ensures a high degree of modularity. In fact, if you are a more skilled developer, you can replace the IDE with your favorite IDE. And if you don't like the SuperCollider language, you can decide to use different languages to ask to control the audio server. So let's suppose you are specifically skilled or trained in Python or in Java or in Haskell. Well, there are clients written for these languages, so you're not forced to use the SuperCollider language, and you can use your own preferred language to ask for audio services to the server. Now, why do this? Well, actually, because it can be useful for various projects, and in fact, there are various clients for SuperCollider server, and the server component has been, let's say, taken away, extracted from this environment and used in various other environments. Why? Because it sounds good, because it's a really good audio generators that can be used outside this whole organization. Of course, the things that I'm saying to you, even if this is a tutorial, are advanced, and we will not discuss this kind of operation. We will stick to the standard SuperCollider way of functioning, which is, by the way, the standard way I personally use. And also, the SuperCollider language is very cool. So it's a nice way of writing code and interacting with audio. Now, how does this communication between these three components works? Well, the communication between the editor and the interpreter works internally, substantially. You have, and we, from our point of view, we know nothing and we do not want to know anything about it. That's why there is a dashed arrow IDE and the block 3 or 4, because it's the same block, Sclang, between IDE and Sclang. The communication between Sclang and the server, let's call it Xint, on the other way, works by means of a specific and very well-known protocol in multimedia, which is OSC, meaning Open Sound Control. Now, even if the name of the protocol refers to sound, Open Sound Protocol, at the end, this protocol has been widely, and it is widely used in making various software communicate, intercommunicate. So it is a protocol using a network protocol, UDP standard, and typically, and this is an interesting feature, because it means that the block Sclang and the other block Xint, they are both able to communicate via this protocol. And this means that this protocol is the easy way in order to communicate from and to these two blocks from other application, from and to other application. Let's say you have a digital audio workstation like Reaper. Reaper supports OSC, and you can communicate. You can make SuperCollider, meaning these two blocks, and Reaper communicate. But it's also Open Sound Control is also used in mostly other multimedia application dealing with video, like let me say, like processing. Processing is able to use OSC, so you can integrate processing and SuperCollider, or VVVV, which is I think Windows only video software, can use Open Sound Control, so you can integrate, communicate these two applications. You might ask yourself, so if I want to make sound, I need to write Open Sound Control messages, because I want to speak with the server, and I have to write standing in the SuperCollider language. Well, yes or no? Yes and no, because as we will see, substantially, there are a lot of linguistic constructs that help us in the communication with the server, so that substantially we will not deal with Open Sound Control, because Open Sound Control is cool, but it's also in a certain way low level, near to the machine. So we will stay a higher level using the possibilities given to us by the language, and you will see that these possibilities are on a higher level. Higher level means near to us as human programmer. So I could have started by making something sound, which is the typical way in which SuperCollider tutorials start, but I prefer to give you the larger picture, so you have an idea of what's going on. So you have to take into account that, well, if you open your SuperCollider package, if you are able to open it to explore its content, you will see that there are these different blocks that are integrated together. Now, given that, if you look at SuperCollider here, you will see that here there is a label named interpreter with a GUI flag, which is green light, so you can go interpreter is active. It means that this block here is working and ready to serve for your purposes. And in fact, we have used it. We have sent messages to the interpreters. We got one error and good reply, in fact. On the other side, if you see here, you see that there is nothing. Well, actually, there are a lot of things, but there is nothing green. It's all gray, meaning it is not working. What is not working? The server. So when you boot the SuperCollider application, you get by default the interpreter as active and the server as inactive. That is, it needs to be started to keep working. Why it is? Well, actually the point is that it doesn't make sense to start writing without an interpreter being capable of understanding you, so it's a waste of time. On the other side, you might start programming without thinking at the beginning about audio, so you just start the server when you're in need of it. So if we have to explore, if you want to explore the integrated development editor, well, I think you can do it by yourself, because at the end here you can see that there are standard menu like new, and you get a new file here, and it's named untitled, of course, and then you can save it and reload it if it has been modified, and so on. If you save a file, you will see that there are different extensions. The standard extension for a written program is SCD, meaning SuperCollider document. And there are other two possibilities that we will not use. One is SuperCollider class file. You will not understand this. You are not understanding actually this now, but you will, but we will not use it. And the other is a specific format to write the help files, because the help files are written in a markdown format, which is a specifically organized format, and they are visually rendered while you are asking for an help file. So if you want to write an help file, you have to write in the syntax and save it in specific location with this extension. We are not dealing with it. So let's go to let's say where is desktop, and we call it test, and we save this empty file, and you see that it gets the SCD extension, so SuperCollider document. Now you can organize various documents into a session. To tell you the truth, it's something that I never do, so it is a possibility that I leave to you to explore if you're interested into it. It means that they get they get organized into a bunch in some sense. Then there is the edit menu. The edit menu is standard one, so you get copy, cut, paste, find, plus some other interesting stuff that we will see later. View is just a visualization menu. Then we get some interesting comments here under the language menu. It refers to some functionalities related to the running of the code. And then there is a menu related to the server. As an example here, you can boot the server if you want. And the interesting point here in terms of interface, and that you have boot server here, and you see that you can do also Control plus B. Well, it might vary, because if you are on OS X, you know that instead of control you get the Apple menu, but that's not the point. You can see it from your own installation. So in order to boot the server, you can press this, you can have your cursor here and press Ctrl B, or third way, you can go here and boot the server directly from here. That's the same things. You can also do another thing, which is this one, s.boot. And s.boot means server please boot. So this is a statement in SuperCollider. There is a change in interface. I hope I will not. Yes, that's it. So this is a small program made by one statement. Technically it is an expression in the SuperCollider language. Now, suppose you write this program, your first program, it's not hello world, but it is s.boot, and suppose you're writing it and you want to execute it, because one thing is to write in the language, the other thing is to run the program. How do you run it? Well, actually, in order to run program, you have to select the expressions you want to execute. Then you can go to language and you can do evaluate selection, line or region, or in this case it's the same, evaluate selection or line. So if we do this, you see that something is starting, and what did happen here? Well, actually the first effect you can notice is that now this is green, this block here is green, and you can see that many things happened here. We will not dive for the moment in details, but you see that this is related to audio generation. It means that it is related to your own machine, your own system for generating sound. So if you have an integrated sound card, you will probably see this integrated sound card here, and it depends on your machine. It also depends on your installation, because by default in Linux all audio applications substantially use jack, and in fact here you cannot see my real hardware audio interface, which is at the moment it is right now it is a Behringer sound card, but you only see jack driver. This is mostly related to Linux. The point is that even if there is this jack thing, jack is an audio application for Linux, the main point is that here you will see information concerning what happens in your audio interface. So the server starts by looking at your sound interface, because of course it has to deal with this interface, because to generate audio is one thing, but the other thing of course is to be able to speak with your hardware. Otherwise there will not be sound coming out from your loudspeaker. So here we have evaluated a line that is a small program containing just one single expression, and we have seen that one thing is to write, the other to execute. So you can keep on writing like this. This means stop the server. Just by writing it, it does nothing. We have to evaluate it. So how do we evaluate it? We know it, language, evaluate. But actually, the point is that you will have to bear in your mind this shortcut, because this is the shortcut you will use always. Control plus return, or a different flavor maybe on various machines, but that's the point. You have to bear in mind this interface. So I will do evaluation by means of, in my case, shift return. So, as you can see, now, after writing it, I have decided to evaluate this other expression, and the result is a command sent to the server, and the server has quitted. Now it is gray again, and I don't know if you can read it, but here you have server exited with exit code 0. Exit code 0 only means everything was all right in Unix style parlance. So, what happened in terms of our schema? Well, the point is that let's consider these two expressions. They are put together. Of course, that it will not have it will not make sense to evaluate them together because we're asking two opposite things: boot the server, quit the server, no? But what happened when we write and when we wrote and when we evaluated these lines? Well, actually, we are in the IDE, of course. We are writing using various possibilities of the IDE. After we wrote, we sent this expression by means of the dashed line to the interpreter of the language. The interpreter program, that is Sclang, is trying to make sense of what we wrote by referring to the language that it knows. Those expressions were written correctly, they make sense for the interpreter. And what are they asking? Well, these expressions are asking to send messages to the server, and so the interpreter understanding our the expression that we wrote, like s.boot, opens a communications via open sound control. See that we had not to deal with open sound control directly, but the interpreter is doing this for us, and goes to the shop in some sense and say, hey, please start working. And the shop, the server, opens and say, okay, I'm ready for other instructions. Now, for the moment, we have only asked the shop owner to open the shop, but once, of course, in order to buy something, to ask for some services to the shop owner, that is the server, we have to have the shop opened. So the first thing, we boot the server. So and once we boot the server, of course, we're able to send this server other messages like this. And we have written a line, and we can evaluate this line. In order to evaluate the line, we can select it. We can select it all, or in case we want to evaluate one single line, it is enough to place your cursor on the line and to press Control Return or Control Enter, it depends. And here something is happening. Probably you are not listening to it because I have to patch the two software, the one I am recording and the one I'm using. I don't know if you can do it. Maybe let's see what's going on here. Well, actually, there are some complications you don't have. Out on no, I need another things, which is this one. These are the good things of being on Linux. No, actually, it's quite modular on the other side. So let's see if I can record this event. Yes, low volume, but that's fine. So as you can see, when I evaluate this line, something audio is happening. So if you look here at the server bar, you will see something changing abruptly. And you see that we have a feedback here. So the post window is very important because it's the way in which feedback is displayed for you by the interpreter. So what is going on is that I am evaluating this line. I am getting feedback from the interpreter through the post window saying, okay, means I understood what you are asking for, and the interpreter is sending a request to the server asking for a specific audio behavior. Just take it as it is. We will discuss this later, but of course it involves audio, so it requires the server. And you keep on evaluating this. Now, you have seen a specific feature of SuperCollider that you're writing code and you're evaluating this, and you're doing this in an interactive way, and you get an immediate reply in terms of sound generation. So that is why SuperCollider is quite powerful, because it generates a very high quality audio in real time in an interactive way. And that is why SuperCollider is at the beginning of a specific music practice, which is live coding. Maybe you have heard about the idea of live coding, which is a bit strange if you want. It's quite fashionable right now. It means that you can use writing as an interface to play. Well, things might be a little bit more complicated, but the point is that actually I am playing central C262 Hertz right now when I want. And I can do this again if I want. And so on. So that's the way SuperCollider works, by integrating various blocks, by providing a sound generator engine, the server, by providing a control for this engine by means of a specific command interface that can be integrated into a language, and in this way you can program by writing, you can program the sound behavior. So maybe there are many things to be collected into your mind for the moment, but this is an important schema to have the ideas clear. Keep in mind that we substantially will not discuss into details what is this schema again, in the sense that we will simply write things in our integrated editor and ask the interpreter to execute the expressions that we are writing, and we will not deal with this communication because it is given for granted. So we will simply use the editor as I am using it. But it is important to keep in your mind this modularity idea, because it provides a source of possible richness, and on the other side, not to keep in mind these structure means that you might do some mistakes that you would not be able to understand. So for the moment we can simply stop here and the thing that I am the last thing that I am that I'd like to introduce is that I will refer as a general source of information apart from the various online resources. I will refer to the book I wrote, which is named Introduction to SuperCollider. It is not a free book. It has been published by Logos Verlag it's in English, in Berlin. The Italian version is freely available. You may say, I do not understand Italian. Fine, but as it is the same book, you can download the PDF online, and you can get all the figure that I will discuss. So the name is Introduzione a SuperCollider by Maggioli. Maggioli is the publisher. So this schema is, I think maybe it has been integrated also in the SuperCollider documentation, or maybe not this one, another one, but you can find it on the book, and if you Google for it, you find it. So first thing, download, everything working. Maybe you can test audio by means of this very simple line. You should get sound and mumble on the whole things. Then we keep on diving into SuperCollider.